I want to prove to you that the cross product vector or the vector that we get from doing a cross product is perpendicular to each of the two vectors that we use to get that cross product. Again, I'm just going to pick vectors out of the sky. It doesn't matter. Let's let u equal the vector 1, 1, 1. And let's let v equal the vector 0, 3, minus 1. I just make these numbers up. So u cross v is going to give me a third vector. Remember, cross product gives us vectors. We get a third vector as an answer. Dot product gives us numbers. We don't get a vector when we do a dot product. We get a number. U cross v then is going to equal, and I'm going to draw my determinant, I, j, k, 1, 1, 1, just reading right across, 0, 3, minus 1, just reading right across. That's going to equal this vector, the unit vector I, times the determinant. What's not in the column, I see 1, 1, 3, minus 1. 1, 3, minus 1. Then I'm going to subtract the j unit vector, draw my determinant, block off those rows, and I see 1, 0, or 1 reading across, 1, 1, 0, minus 1. 1, 1, 0, minus 1. Finally, I'm going to add my k vector times that determinant, which is 1, 1, 0, 3. This becomes 1 times negative 1 is negative 1, minus 3 is minus 4, minus 4i. This becomes negative 1 minus 0 is negative 1, but I've got a minus sign right here, so this becomes a plus j. And then 1 times 3 minus 0 times 1 is 3, so that's going to be a plus 3k. This is my cross product vector that I get when I do the cross product of these two vectors. So I get a third vector, which we can of course also write as minus 4, comma, 1, comma, 3. So I've got three vectors here, and what I want to show you now is that this vector is perpendicular to each one of these. Do you remember how we do that? How do we show perpendicularity? I will wait 3 seconds. We do the dot product. So I'm going to write this third vector here, minus 4, 1, 3. I'm going to erase everything else and do the dot product. I'm going to do the dot, let's call this one the vector t. So I'm going to do u dot t. And if you remember, that's equal to the components of the I multiplied together, plus the components of the j multiplied together, plus the components of the k unit vector multiplied together. So that's going to be 1 times minus 4 plus 1 times 1 plus 1 times 3. 1 times minus 4, 1 times 1, 1 times 3. This is minus 4, this is plus 1, plus 3 equals 0. The reason I can be now sure that I've got what I want is, remember our for the dot product we have this function, or this expression, that the cosine of the angles between two vectors is equal to their dot product divided by their magnitude. I'm not going to calculate what the magnitude is for this vector or for this vector. I know they're both greater than 0. They have some length. It may be very long, it may be very short, but it's not 0. Because the length of any vector, the only vector that has length of 0 is the 0, 0, 0 trivial vector. So this is, the denominator is not 0, but I've just shown that this dot product is 0, which means that the cosine of the angle between these guys is 0. And if you remember, there's only one angle that satisfies that. Well, there's the 270, but that's trivial. 90 degrees. I have shown that they're perpendicular. The same thing's going to happen when I do this vector and this vector. They're going to be 90 degrees apart.